Okay, science part 2. Today our goal is to talk about what the differences between balanced and unbalanced forces are. Balanced, unbalanced. So I want you to think about a scale, okay? And let's say I have something that is super heavy. What's going to happen to my scale?
It's going to go down.
It's going to go like this, right?
Mm-hmm.
What if I have two things that are equal? So what does balanced look like? Is balanced this one or this one?
This one.
It's this one, right? It's equal. So when we have balanced, we're thinking about equal. When we have unbalanced, what happens?
One falls down.
One falls down. So I'm going to put my tape roll up here. Okay? It's round, right?
Mm-hmm.
Is it moving at all?
No.
No. Do you know why it's not moving?
Balanced.
Because the forces are balanced. Okay? Think about gravity. What do we know about gravity? What do we know about gravity, Blake?
Gravity pushes it down and up.
Gravity is the reason why I'm not floating in space, right?
Yeah.
Gravity is what's keeping me centered and balanced. But Miss Cialino is going to be the force to reckon with. Are you ready? What did Miss Cialino just do? I pushed it, so what happened with the forces? What happened with the forces, Camden?
The forces made it move.
The forces made it move. Well, guess what happened?
What?
It's no longer balanced. Then it becomes unbalanced. So what happens is when you have something that's still and stays there, guess what? It's balanced. The forces are being pulled. Well, what happens if I have my tape up here?
Then it isn't balanced.
And what if I were to say, oops, and I let it go? What's going to happen? Demi, let's put that away, please. What's going to happen? The gravity is going to cause the object to be unbalanced, right? So are you ready? But guess what? What happened now that it's on the floor? It's balanced. But when it was up here and I let go, what happened?
It was not balanced.
Unbalanced. So that is the difference between balanced and unbalanced. Balanced means they're equal. There's equal forces being pulled onto it. Unbalanced means they're not equal. Hi.
I have a grading sheet for DOL.
I didn't print it.
Okay, that's fine. Never mind.
Okay, but do you want mine from today? Okay. All right, so now what is going to happen is we're going to take a look at what force is, okay? And we're going to talk about the difference between balanced, unbalanced, and we're going to continue with that. I was trying to pull everything up on the computer. And of course, just like life, Andre, technology does not feel like working for me today.
Like Emily.
Oh my goodness, it's just not working. So what I do is, you're in luck though, I do have a copy of it. Okay, so we're going to take a look at chapter 1 here. Force. A force is a pusher. A pull? Wait, did we hear that before? A force is a pusher or pull? Have we heard that?
Yeah.
Oh my goodness, that's what we spent all day yesterday talking about. Okay, let's look at this. It says, think about how you start your day. You wake up and you push yourself out of bed? If you're sitting there, don't you like go down and you push yourself up and you get out of bed?
No, I roll out of bed.
So you roll, which is kind of pushing yourself to get your feet up, right?
My mom wakes me up and I go like,
So your mom picks you up?
no, she doesn't pick.
Oh.
She wakes me up.
She actually does.
You pull a box from the shelf and pour your cereal into a bowl. You lift a milk carton and pour the milk.
Yes, I do.
Then you pull spoonfuls of cereal to your mouth, or whatever it is that you eat for breakfast. Right? Don't you pull it into your mouth? So remember, push is pushing it away from you. It goes away. Pull means it's coming for you. So on Monday, when you eat your breakfast, I'm going to make note of when you pull that food into your mouth. Oh, no. Missy, you are right. I do pull food into my mouth.
No.
You might not wake up thinking that you are using forces. But you are. You're constantly using forces all the day long. Look, I'm pulling my foot from the floor.
And
I'm pulling my foot from the floor. You do it when you walk. You're pulling your hand and raising it, right? Oh, but you don't even realize that you're doing that. You're pulling your lips apart every time you talk. Oh.
That's
So,
wow.
a force is a push or pull. Each time you push or pull something, you're using a force. Every time something starts to move, mouths, talking, they're starting to move, right? Yes? No? Something stops moving. Oh, look. But closed. Or changes directions. Forces are involved. Forces are every day, all day long, right? You may not realize it, but they are. Forces change. Whenever you cause something to start to move, stop moving, change speed, or change direction. You use forces. Think about a soccer ball. A soccer ball comes rolling towards me. What's going to happen?
You're gonna kick it.
I'm going to kick it, and what's going to cause it?
You?
It's going to get pushed away from me, right?
Yeah.
Oh my gosh, guess what? There was somebody outside yesterday when we were outside for recess, and they were throwing the frisbee to get it over the tree. I thought that frisbee was going to come straight for my head. So what was I going to do to stop the frisbee from hitting my head?
You were gonna run?
I was going to put my hands up to push the object away from me because it's a force,
Oh, I
right?
would just run.
Motion is a change of position. Here we go. Think about kicking a ball. A force from your leg causes the ball to move. The ball is pushed into motion. The force of the kick changes the ball from not moving to moving. As the ball changes location, it is in motion. A bike rider pushes the bike pedals. Huh. So when you go riding on your bike, you are pushing the pedals on the bike. So he pushes the handlebars to change directions. Oh. To zigzag around the cones, the rider uses the force to change this direction and speed. Forces can also make things stop moving. When the rider is ready to stop, he will stop pushing the bike pedals. Or if you have the brakes at the top, look, he will pull the bicycle brakes in a way that slows him down. Do you have a question?
Yes.
Yes.
Does drinking your water technically count as pulling? Because you're like usually sipping it out of like a straw.
Yeah, you're sipping and you're pulling the water up right into your mouth. Okay, so the difference between balanced and unbalanced. Forces can be balanced or they can be unbalanced. Kind of what we were talking about today, right?
Mm-hmm.
Sorry. How about I just move it like that? There we go. When two equal teams are playing tug of war, have you ever played tug of war before?
Yes, we used to at school.
So you have one on this side, one on this side, and I'm the middle. What's going to happen?
You're gonna get pulled.
Pulled, right?
Yeah.
In each direction.
But that was
The rope may not move at all. There is no motion. If you add up all the forces acting on the rope, they are equal. It's happened before, right?
Yeah.
The pull from one side equals the pull from the other. So if I'm the tug of rope going, tug of war rope, this side and this side, if they're equal, which way am I going to go? Nowhere. Because,
Nowhere.
So what does that mean? Am I going to be balanced or unbalanced?
Balanced.
I am going to be balanced. The
But
forces on the rope are the balanced forces.
But-
Yes.
but if there's three people on this
Hold on,
side.
we're not there. Hold that thought. Okay? What happens to the rope when one side pulls with greater force than the other? So, there's more people on this side. What's going to happen?
They're gonna pull you.
You're gonna pull.
I'm going to go that way, right? Yes?
Yes.
Forces on the rope become unbalanced. So that means there's going to be a greater motion in one direction. Okay? So when they're balanced, it's equal. When they're unbalanced, it's Not equal. Okay. One team will then win the tug of war. How lucky are they? Imagine the tug of war rope sitting still on the ground. It's on the ground. I'm not going to go ahead and lay on the ground because that would be kind of silly, right?
Mm-hmm.
You might be surprised that the forces are acting on it. All right, I'll do it.
Oh, I want to.
There's forces acting on me right now.
There is?
Yeah.
What forces are acting when I'm on the ground? What forces are acting on me when I'm on the ground?
The force of gravity pulling you down on the floor.
The force of gravity. Gravity is a force that is being pulled down. So, the ground also pushes up against the rope. So the ground's pushing up, the gravity is pulling me down, so what is it? Is it balanced or unbalanced?
Balance.
It is exactly right. It is balanced. When something is sitting still, just like my tape, it is being balanced. When it is up here and it falls down, it is
Unbalanced.
Unbalanced.
oh my goodness, I think we're starting to get this, right?
Yes.
Yeah, it's pretty much.
All right, gravity is a pulling force. Wait a second, we already said that? We already said gravity is a pulling force, right?
Yep.
Blake, do you have a question?
Yeah. It's just like when you get on a trampoline and you jump it.
It pulls you right back down. Absolutely. All right. Forces are all around you. Wait a second. Didn't I just say that, Demi? Forces are all around us. Right? I know. You can see or feel many of them, especially when they are unbalanced. That's when you see them the most, Blake. And that is also when you feel them the most. You feel forces when someone pushes you on a swing. Do you feel that force?
Yes.
Yeah, someone's going to push you, you're going to go whoosh, right?
Yeah.
You feel a pull when someone tugs on your shirt.
Why would they tug on
Wrigley would be a perfect example.
But you can't
When I don't give him attention, what is he going to do?
tug on your shirt.
Tug on my shirt, causing an unbalanced force. You might not see or notice it, but the force of gravity pulls on you at all times.
I know that.
Earth's gravity is a force that pulls objects down to the ground. When you are sitting still, are forces acting on you?
Yeah.
Yes, gravity is acting on you. So if I'm just sitting here, you're just sitting right there, you're sitting there, you're sitting there, everybody's sitting in here. What is going on?
I'm balanced. I'm balanced.
Gravity is doing what to all of you?
Pulling us down on the chair.
Exactly. The force of the ground is pushing upward on your body.
Yeah.
And the force of gravity is pulling you down. You don't float up or sink down because the forces are
Equal.
balanced. They're equal. Whew. If you jump up, everybody stand up. Let's jump up. Ready? 1, 2, 3, jump. What happens?
Gravity pulls us down.
Gravity is pulling us back down. Okay, sit back down.
I know a lot about gravity.
Sit back down. Annie, over. Please. If you jump up the push, you apply with your muscles, and then pulling you down. Okay, a force has direction. Let's look at this picture.
Doggy and another doggy.
Yeah, that's not Wrigley. Neither one is.
It kind of.
Okay, the dogs in the picture play tug with the rope toy. When the dogs pull the toy with the same amount of force, the toy does not move. The forces are balanced. They're equal. Carson, put it away. The balanced forces have the same strength, but the forces are pulling in opposite directions. One way to understand forces is to draw arrows to represent their direction. So if you look, this dog's going, Jasper, this way. This dog's going this way. Those are showing that the forces are being balanced. They're not pushing together. They are actually balanced by being pulled apart. Okay? So, a force has strength. Look at the picture. See the picture?
Who's gonna win?
Which dog do you think will win the tugging match?
The bigger one.
Why?
Because it's on pause.
Oh.
Well, the other one's standing up completely, and then the other one isn't.
The brown and white dog on the left is bigger. It can probably pull with a stronger force. So an example would be when Mr. Wrigley and Mr. Charlie get together. So Charlie's my parents' dog. Charlie's older, okay? Charlie is a lot older, and Wrigley is super, super strong. Like, I can't even play tug of war with him. He's that strong. So what happens is Wrigley has a stronger pull. What is that, balanced or unbalanced when one is stronger than the other? Unbalanced. So, when two forces of different strengths pull on the same object, the object will move toward the stronger pull. When two forces of different strength push on an object, the object moves away from the stronger push. So, I'm being pulled in two different directions for tug of war. It goes towards the stronger pull, towards it. However, when it's a push, the stronger force will push it away. Can you predict if something will move when it is pushed or pulled? Do you think you can? If you think carefully about strength and directions of all forces on an object, you can predict the motion of the object. Try it yourself. You can draw pictures and arrows to help explain what causes something to move or stop moving. So, in our notebooks, or for those that are going to be doing their remote learning, your job is to take and draw a picture. So I'm just going to flip this over. You're going to draw a picture and an example of an unbalanced force. And I want you, oops, you can't even see that. Man! And I want you to draw a picture of a balanced force. Balanced, unbalanced. I want you to draw an example. So let me give you, don't start yet, please. Let's think of some ideas. What two objects can we use? Give me two objects.
A water bottle and a pencil.
Okay, how would you make it a balanced force?
Oh, you want a balanced force?
Mm-hmm. Yes.
A balanced force,
Give me two things. What if we did dogs? Could we do dogs?
Yep.
No.
Well, how can we not?
Because there's a lot of dogs using their force. You want us to come up with a picture of
Look.
we want the force to
Is this a balanced force? Are they moving any direction?
No.
Is that an example of a balanced force? Is this an unbalanced force? Is that an example?
Yes.
Okay, what about an example of a ball? Can we make a ball a balanced force?
Yeah.
How?
Bye.
Making it stable, not moving, right? How can we make a ball an unbalanced force?
By throwing it.
Throwing it, kicking it, chucking it across the way. Absolutely, you can make it an unbalanced force. All right, let's think of another thing. What about a leaf on a tree?
You can make that balanced and
How? How can I make a leaf on a tree balanced? Gabe.
You can put it on another leaf and it would be steady.
So when it's steady, it's not moving. How can I make that leaf on a tree unbalanced? Zach.
Need to
Huh?
throw it.
Throw a leaf? Okay, how else can I make it unbalanced, Emily?
When the leaves fall off the tree.
With the wind. You can have the wind blowing. Look out there. The leaves are unbalanced right now because the wind is blowing. But when the wind stops, they're unbalanced. So I want you to think of an object and how you can make that object, or if you have two dogs being pulled, whatever it is, I want you to come up with an example of balanced and an example of unbalanced. Got it?
Yep, got it.
In your notebooks. Ready? Go.
All right, good.